All right, welcome back, Algebra 2 students, to graphing exponential functions. The first function I'm going to give you is y equals 2 to the power of x. It's the whole function. If I put a 1 in for x, that means 2 to the power of 1. Means y equals 2 to the power of 1. It's pretty easy. That's just 2. If I put a 2 in for x, that means y equals 2 to the power of 2. That's 4. If I put a 3 in there, that's y equals 2 to the power of 3, which is 8. If I put 0 in there, this is where we got to think a little bit. Y equals 2 to the power of 0. Anything to the power of 0 is 1. You can confirm that. You can check on your calculator or ask Siri to do that for you. If I put a negative 1 in there, y equals 2 to the power of negative 1. Don't forget that's the reciprocal of 2. That's half. You can either write half as a fraction or a decimal. Either way doesn't bother me. If we try negative 2, that's y equals 2 to the power of negative 2. That's the reciprocal of 2 squared, which is 1/4. And again, you could write that as a fraction or a decimal. Either way doesn't bother me. So let me get rid of some of this stuff. Now when I graph these points, I always kind of like to start here. You have the point 0, 1. The next point that you have is 1, 2. That'd be located about here. The next one is 2, 4. I'm just graphing these points. It's 3 and that's 4. Now some of you are like, oh, look, that part looks like a parabola. It really does not. I mean, it's just simply not. Here I go back 1 up half, and then back 2 up a 4th, and back 3 up an 1/8, and so on and so forth. The domain of this function, it does go far left and far right. So for the most part, these are going to be all real numbers. The range of this function, you may think that it eventually touches the x-axis down here and has a y value of 0, but it really would not. Your y values go from, as you work down, they get larger, they get double. Here they get cut in half. So half of a 4th is an 1/8, half of an 1/8 is a 16th. You always have half of something. Think of a candy bar. You continue to break it off and give half to your sibling. You would still have something. So your y values are above 0. They do not include 0. Alrighty. Next one we're going to look at is y equals 3 to the power of x. This may or may not be on your homework. So again, if I put 1 into this function, I get 3. Remember, we're substituting these x values, in here. So these are really just powers of 3. 3 to the power of 2 is 9. 3 to the power of 3 is 27. 3 to the power of 4 is 81. Very good. Anything to the power of 0 is 1. And if you check your pattern, we're always tripling. We started at 1 and we tripled. We work our way up. Negative exponents mean reciprocal, so that's the reciprocal of 3, and this is the reciprocal of 9. Sorry about that. That was written poorly. And so on and so forth. As you work your way up, we're kind of multiplying by a third. If I graph these points, we still have the point 0, 1 here. The next point we'll encounter is 1, 3. So 1, 2, 3. It's about there. Kind of a stretched out version of the last one. Again, the domain is all real numbers, and the range is everything above 0. Imagine you have a candy bar and you always keep a third of what you had previously. You're always going to have something. Alrighty. Gotta be very careful with this one. This is going to be tricky. This is going to be y equals negative 2 to the power of x. That's how it looks, but you'll notice that negative 2 is not in parentheses. So if I were to put a 1 in there, what you really have, I know this is stinky, is you have the opposite of 2 to the power of 1. That's really what you have, which is negative 2. If I put a 2 in there, I have the opposite of 2 squared, which is negative 4. The next one would be negative 8. The previous one would be negative 1. When I put a negative exponent up there, I have the opposite of the reciprocal of 2. It's negative 1/2 and negative 1/4. And now you're thinking, good luck graphing it on that. I'll just slide that up. Clever. Eee. So the function this time would look like this. The domain this time is still all real numbers because it goes from far left to far right. The range is everything below, remember that looks like the letter L, below 0. And then I just have one more function to talk about. This time I'm going to have a number here, 5, and then we're taking 2 to different powers. When I put a 1 here, it's true that 2 to the power of 1 is 2, but we constantly have to take whatever we get here, multiply it by 5. 2 times 5 is 10. The next one, putting a 2 in there, you have to notice that 2 squared is 4, 4 times 5 is 20. When I put a 3 there, remember you still have 5, but now you have 2 cubed. 2 cubed is 8, and 8 times 5 is 40. So again, we're still doubling. It's just our initial value was 5. And that can be confirmed here by putting a 0 in. Anything to the power of 0 is, anything to the power of 0 is 1. And 5 times 1 is 5. So according to this pattern, you started at 5 and doubled. This time we'll just call this 5. The next one would be the point 1, 10 and 2, 20. And it's kind of having that certainly that same shape. It's what's happening previously. When we have a negative 1 there, you still have a 5 here. 2 to the power of negative 1 is half. So what you end up having is 5 times half. If I multiply across, I get 5 halves, which I can write here or just evaluate it as 2.5. That'd be about here. The previous one would be half of that. We'll just think money. That'd be about here. So it certainly has that same basic shape. As you move from left to right, or on your graph, on your table from top to bottom, it's always doubling. That's double, that's double, 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 double. So here's the key parts here in this equation. You have what's called the initial value. That's here, that's your y-intercept. That number is your y-intercept. And this is what's called your growth factor. It's basically what's happening each time. You're doubling. And again, the domain is all real numbers. The range is y is greater than 0. For this function, I could give you any starting point I wanted. That's 10. And now we're multiplying by 4 each time. We're quadrupling. That tells me, without really even doing a bunch of math, your initial value is the point 0, 10. Let's call that 10. You're constantly multiplying by 4. That's 40. That's 160, so on and so forth. Here we have to think about what is a fourth of 10. It's 2.5, and so on and so forth. Again, it'll still have that basic shape. You get stuck, use Desmos. Alright, good luck.